Hi class, this is Neil, and this is the second video in lesson 4, which is a continuation of our look at the unit circle. In this portion of the lesson, I'll be looking at page 2 and the example for this part of the lesson, where we're given an angle or given a value for theta, and we need to find the xy point of the terminal side of that angle. All right, so let's look at the first example. All right, so the angle theta is 160 degrees in standard position, and it intersects a circle centered at the origin with a radius of 10 at the point xy. We need to determine to the nearest integer the value of the coordinate xy. All right, so let's sketch in what we know. So first of all, we know that there is an angle theta at 160 degrees. So I've sketched in the initial side of my angle. The terminal side is somewhere between 90 and 180. So 160 is about here. So that's my angle theta. And I know that angle is 160. Now we know that it intersects our circle at the point xy. Let me just erase that. Now we also know that the radius of that circle is 10. And remember, the radius is going to be the length of the line segment that goes anywhere from the center of the circle to the edge. So my radius here is 10. All right, so I can sketch in my reference triangle to kind of help me see where my x and y values would be located at. So here's my reference triangle with the reference angle. X is really going to be the base of my triangle, or my adjacent side. And y, the y value is really going to be the height of my triangle, or the opposite side. All right, so let's think about our ratios. So we've got sine of theta equaling opposite over hypotenuse. We've got cosine of theta equaling adjacent over hypotenuse. So we're going to use these ratios and the fact that we know our value for theta to help us solve for x and y. All right, so first sine. So I would write an equation, sine of 160, or 160 degrees really, is equal to my y value over my hypotenuse, which is 10. All right, so to solve for y here, I would multiply both sides by 10. And I would get y equals 10 times sine of 160. Now I'll need to turn to my calculator to see what this is. Make sure I'm set in degrees. It's important. And now I'm going to input 10 times sine of 160. That gives me 3.42. So I'll write that here. Y equals 3.42. Now we're supposed to determine to the nearest integer. So that really means y is going to equal 3. All right, so next let's look at cosine. We'll do that maybe in a different color. So let's do it in green. All right, so cosine is the adjacent side. All right, so that's x. All right, so I'm going to write cosine of 160 equals x over 10. I'm going to solve that the same way. So multiply both sides by 10. All right, it's going to cancel. And I'm going to get x equals 10 times cosine of 160. I'm going to have to turn to my calculator now.
Navigation option.
All right, I've got negative 9.39. And now because it's to the nearest integer, x is going to equal negative 9. So the value of the coordinate then is going to be negative 9, comma 3. Which makes sense because we're in quadrant 2. So our x value would be negative, our y value would be positive. All right, there are a few practice problems to do with this idea. The key here is really to identify your sine value and your cosine value. And use what you're given about the radius and the angle to help you solve for one of those sides.